Okay, if not, let's continue our section 5.2. In 5.2, as I said earlier, we have the linear equation and we have the three variables. So we have to solve the linear equation with three variables, and we use the elimination method. Okay, now we have two more examples here, and I want to start from example 4. Okay, then we'll come back to example 3. So in example 4, so we have the three equation. So let's name it. So we have x plus z equals to 3. So let's call it equation 1. Okay. We have 3x plus y plus 2z equals to 0. Let's call it equation 2. And we have our equation third, 4x plus y plus 3z equals to 5. This is our third equation. Okay, we have a three different equation and we need to solve. So we need to find a common value for x, y, and z, which is true for all of these three equations. And we use the elimination and we also use the substitution here. So the very first thing is that we try to eliminate one variable, and it doesn't matter what variable you want to eliminate. Okay, so from these three, what would be easy for us to eliminate? Which variable is easy to eliminate here? Okay, now y, now the reason is that, now if we see the coefficient of y, so in the second equation the coefficient of y is positive 1, in the third equation the coefficient of y is positive 1, right? So what we need, we just need a different sign. Now how do we get that? Okay, that's right. So we multiply equation 2 or 3 by -1. Okay, so let's take equation 2. So it's 3x plus y plus 2z equals to 0. Let's multiply this equation by -1. Okay. So this is a -1 times 3x, that is -3x, -1 times positive y, -1 times positive 2z, that is -2z equals to 0. And let's add this equation with our equation 3. Now we're going to add this equation with equation number 3, which is 4x plus y plus 3z equals to 5. So we are adding. Okay, so we have -3x plus 4x, that is x, -y positive y cancel. Okay, then we have -2z plus 3z, that is plus x plus z equals to 5. Okay, so let's call it our equation 4. So x plus z is equals to 5. And what is our equation 1 tells us? So when you add x and z, same x and z, you have to get 3. What does it mean here? So from 4, we get that when you add x and z, we get 5. But it's given to us that when you are adding x and z, it's equals to 3. Now is there any conclusion we can make here? Okay, not real. I had no solution. Okay, now let's let's eliminate one variable from equation 1 and 4. Okay, and we get no solution. Okay, so let me write equation 1 here, x plus z equals to 3, and equation 4 here, x plus z equals to 5. What variable do you want to eliminate here? It doesn't matter, right? We know it looks like if we multiply one equation by -1, both variable is eliminated, right? So let's multiply our equation 1 by -1. So we multiply by -1 and add. So after we multiply, we get, okay, let me erase this part here. So when we multiply equation 1 by -1, we get -x, -z equals to -3. We add this equation with equation 4, which is x plus z equals to 5. This is our equation 4. We are adding. Now -x positive x 0, -z positive z 0. So we have 0 on the left and 5 -3, which is 2. And we have 0 equals to 2, which is not true. It means there is no solution. Okay, so this is false. So this linear system has no solution here. Okay. no solution. So when you are solving the linear equation, if you get no solution, it's normal, okay? Do not get confused, do not get stressed. So sometimes you may get no solution. Sometimes we might get infinitely many solutions. Yes?
So this Gaussian elimination is just the same thing?
Gaussian is the name of the mathematician, okay, who introduced this method. Okay, so it's like, it's the same method. Okay, the Gaussian elimination is the name of mathematician, okay, who is a mathematician. He introduced this system and it's named after him. Okay, so it's the same one. Now we do have a matrix, but we'll cover that in our next classes. Okay, right now let's use the elimination method to solve this system of equation. Okay, do you have any question on this one? Okay, now let's go back to our equation, example number 2. Okay, so here, so what differences do we find between example 1, 4, 2, and 3? So if we compare equation 3 and 4, what difference do you find? I know the coefficients are different, right? We do have the same variable, but it's still, is there anything? That's right, the number of equation is not same, right? So in example number 3, we are given 2 equation, but in example number 4 we are given 3 equation. Okay, now let's see here and try to solve this equation and let's find the solution here. Okay, so we have 2 equation. Let's call it equation 1 and 2. So this is 1, let's call it, and let's call this is 2, and let's try to eliminate one variable. So what variable is easy to eliminate here? Y, right? And we just need to add. So let's add these 2 equation. If we add positive y, negative y, that is 0. So we have negative 3x plus 5x, that is 2x. Okay, negative 2z plus 4z, that is positive 2z, equals 1, negative 1, that is 0. Okay, now let's solve this equation for one variable. Okay, you can solve this equation for x or you can solve for g. Now let's solve for x or z, does not matter. So if we are solving this equation for g, what do we need to do? We need to get rid of 2x from left side, right? So let's subtract 2x on both sides. So positive 2x, negative 2x cancel. So we have 2z on the left equals to negative 2x. We have 2 on both sides. So let's divide both sides by 2. And from here we get g equals to negative x. So our g is equals to negative of x. Okay. Now we substitute g equals to negative x in any one equation. Okay. Equation 1 or 2, it doesn't matter. Okay, let me take equation 1. So our equation 1 is negative 3x plus y minus 2z equals to 1. So for g, we substitute negative x. Okay, for every g in equation 1, we substitute negative x. So we have negative 3x plus y negative 2, and for g, we have negative x equals to 1. By adding equation 1 and 2, we know g is equals to negative x. So we substitute g equals to negative x in any one equation, 1 or 2, it does not matter. Now let's simplify here. So we have negative 3x plus y, negative 2 times negative x, that is positive 2x equals to 1. We have a like terms here. So we have negative 3x and positive 2x, these are like terms, and let's find what is y equals to. Okay, so we have negative 3x plus 2x, that is negative x plus y equals to 1, and from here we can find what is y. So let's add x on both sides, and our y is 1 plus x. Now here, what we see here is that we have our g in terms of x, we have y in terms of x. Okay, so we express the solution we express the solution for y and z in terms of x, and x is any real number. Okay, now from here what can we say about the solution? Our g is negative x, okay, y is 1 plus x, and x is any real number. That's right. So we get infinitely many solutions. Okay, our x is a real number. We have an infinite real number, right? So it depends what x you choose. Okay, if you choose x equals to 0, let's see, if x is 0, what is our g? G is 0. What is our y? 1 plus 0, 1. So 0, 1, 0 is one solution. Now if you choose x equals to different number, you get a different solution. Since x is a real number, we get infinitely many solutions. Okay, and it depends on what number you choose for x. So here we can write the solution. Our x coordinate is x as it is. Okay, so our solution is, so our x is x as it is, our y is 1 plus x, and our g is negative x. So we have the solution. Okay, and this solution is infinitely many solutions. So and the reason is that x is a real number. We have an infinitely many real number, and if we substitute any number for x, okay, we get a different solution. So here we find infinitely many solution. Okay, infinitely many solution. So there are three different cases. We might get exactly one solution, we might get no solution, or we might get infinitely many solution. Okay, okay, yeah, if you have the two equation with the three variables, then you get the infinitely many solutions. Okay, so in order to solve any equation, we must have the number of variables has to be same as the number of equation. Then only we can find the solutions. Okay, like if you have a two variable, you must have at least two equation to solve. Okay, if you have a three variables, you must have three variables to get the final solution. Okay, similarly, if you have a four variables, then you must have four equations. Then only we can solve. Otherwise, we get the infinitely many solutions. Okay, so this is all about section 5.2. Okay, do you have any question? Okay, if not, we'll go back to our section 2.1 and start the review for our exam 2. Okay, and from 5.1 and 5.2, as I said earlier, you're gonna practice three problems. One problem is solving the linear equation with a two variable. Second problem is solving the linear inequality with a two variable, and the last is solving the linear equation with a three variables. So only three problems you should know for exam 2 from these two sections. Okay, but from 2.1 and 2.2, you're gonna have a lot. Okay, so let's go to the revision. Okay, so let's make a review for section 2.1 and 2.2. Okay, so it's on your page number. Okay, 2.1. So it's page, if you have book, it's page number 213 and 214. Okay. Okay, now let's go ahead and start that one. Okay, today I will help solving some of the problems from the review. Okay, and tomorrow we'll make a group and we'll just practice in a group. Okay, and I will help you in a group. Okay, and for today, just let me go ahead and just solve a few problems from the review, and tomorrow we'll work in a group. Okay. Okay, the very first thing is a section 2.1. And we are asked to find the slope of a line passing through the points. We are given a points and we are asked to find the slope. Okay. Now let me take one example here, number 1, that is negative 2 0. So we have this point and the other point is 0 5, and you are asked to find the slope. And how do we find the slope? Slope is m, right? And what is slope? M equals to the difference in y coordinate, y2 minus y1, over difference in x coordinate, x2 minus x1. So let's call our first point, this is x1 y1. Let's call second point as our x2 y2. It does not matter if you switch, you can call your first point as x2 y2 and the second point as x1 y1. We still end up getting the same thing. And let's substitute. The remaining is you substitute your x1 y1 x2 y2. Now here our y2 is 5 minus y1 is 0 divided by x2 is 0 minus x1 is minus 2. So we have 5 minus 0, 5, 0 minus minus 2, that is plus 2. So we have 5 over 2. Now what does it mean by this slope? So slope is 5 over 2. What does it mean?
It's going up 5 and over 2.
Okay, so you go right 2 units, right? And you go up by 5 units. If it's positive, you're going to go up. If it's negative, you're going to go down. Okay. Now the next number 3 is still you are asked to find the slope. I hope you can try this one, and I will go to number 5. And you are asked to find the equation of a line, okay, in the form of y equal to mx plus b, which is slope intercept form, passing through a point. So we need to find an equation of a line. The line is passing through a point. Okay, the point is given to us 4 negative 1, okay, and with a slope negative 2, and slope is negative 2. So you are asked to find equation of a line. Okay, this is the line. We are trying to find the equation of this line. This line is passing through a point 4 negative 1. So we have a point somewhere here whose coordinate is 4 negative 1, and the slope of this line m is given as negative 2. So we know a point on the line and the slope is given as negative 2. And every time if you are looking for the equation of a line, we have the two form that you're going to use. Slope intercept form, and the next is point slope form. You have the two options to use, okay, every time. The first option is you might use y equals to mx plus c. Did we use a b or c? Okay, we had a b. Okay, what mx plus b. So this is our slope intercept form. And the second one is we have point slope form, which is y minus y1 equals m times x minus x1. Okay, these are the two options that we're going to use here. Now, which one would be the best here? The first one or second one? Okay, how do we know that?
Because you have only the two coordinates, the x and y.
Right, so we are given a point. So this is your x1, this is your y1, and m is given, and which is in our second. So we know x1, we know y1, we know m. So you substitute the values. Okay, so we have y minus y1 equals m times x minus x1. Okay, so let's call this is our x1 y1. We have y as it is. Y1 is negative 1 equals m is negative 2, x minus x1 is 4. Now we simplify. Y minus times minus 1, that's positive 1, equals, you distribute 2 here, distribute 2 for the x as well as negative 4. Negative 2 times x, that is negative 2x. Negative 2 times negative 4, that is positive 8. Okay, and your final answer has to be in this form. Okay, slope intercept form. That's the instruction given to you. So it means you are solving for y. So we subtract 1 on both sides and we get our final answer. So positive 1, negative 1 cancel. We have y equals to negative 2x plus 7. And this is the equation of this line, whose slope is negative 2 and passing through a point 4 negative 1. Any question? Okay, so this is number 5. Okay, number 6 is pretty similar. It's a vertical line passing through the point 50. And what is the slope of a vertical line? It's undefined, right? And the vertical line has an equation of the type. So if you have a vertical line, so this is x-axis, this is y-axis. If you have a vertical line, then its equation is every time x equals to the x-intercept. So if this is a, then x equals to a is the equation of a vertical line. Okay, and for the horizontal line, so this is your horizontal line, and every horizontal line has an equation y equals to y-intercept. So this is your y-intercept. If this is b, y equal to b is the equation for this line. Now our x-axis and x-axis is the horizontal line, right? What would be the equation for x-axis from this definition? So what would be the equation of x-axis, because it is a horizontal line, and from our definition y equals to b is the equation for every horizontal line. Okay, y equals to 0. Okay, yes, so y equals to 0 is same as x-axis. So if you have x-axis or if you have a line y equals to 0, it's the same thing. We are talking about the x-axis. Okay, so if you have a y equals to 0, then that is your x-axis. What about for the y-axis? What would be the equation for y-axis? Y-axis is a vertical line, and the equation is x equals to 0 because its x-intercept is 0. Okay, the distance of y-axis from y-axis, that is 0, right? So there is no distance. So x equals to 0 is your y-axis, y equal to 0 is x-axis. Do not get confused. Okay, all right, now let's go to the next, number 9. So we need to find the equation of a line passing through the points. Okay, we are given 2 points. Okay, so one point is given as -8, -3, and we have the second point whose coordinate is 12, -7, and we are asked to find the equation of line joining these 2 points. So you are given 2 points. Okay, and the coordinates is given to us, and we need to find the equation of a line joining these 2 points. Again, we are finding the equation of line. So we have the 2 options to use: y equal to mx plus b, or y minus y1 equals m times x minus x1. So these are the 2 options that we're going to use. Now for the first option, in order to use first option, we need to know what is slope of a line. We need to know what is y-intercept. Now is slope given for us? Do we have the y-intercept? Okay. Now for the second one, if we have a 1 point x1 y1, and if we have a slope, we can use the second option. Now for the both option, we need to know what is slope, which is not given to us. But is there any way to find the slope here? We can find the slope, right? Okay. Now we don't have the y-intercept, so we're gonna go with the second option here. Okay, because we know the 1 point. So let's find, the very first thing here is that we will find the slope of this line. So m, which is y2 minus y1 divided x2 minus x1. So let's call this is our x1 y1, this point as x2 y2. Now you substitute. Your y2 is -7 minus y1 is -3 divided your x2 is 12 minus x1 is -8. So we have -7 minus time -3, that is +3, divided by 12 minus time -8, that is +8. So -7 plus 3 -4 divided by 20. We can simplify this. 4 times 1 is 4, 4 times 5 is 20. So we have -1/5 as a slope. You all can find the slope, right? Now you choose the second option here and you substitute slope and x1 y1. So we have y minus y1 equals to m times x minus x1. So we have y as it is. You are not substituting for anything for y and x, okay? Only for y1, x1. X and y, they represents every point on the line. They are the general representation for the points on the line. So we have minus, our y1 is -3, -3 equals, our slope is -1/5, x minus x1 is -3. Sorry, x1 is -8, so x is -8. Now we simplify this one here. So we have y minus times -3, that is +3 equals to, okay, we have -1/5. Let's simplify inside the parentheses. We have x, negative times -8, +8. Okay, now you distribute -5 to x as well as +8. So we have y plus 3 equals to -1/5 times x. X times 1 is x over 5, right? Then we have -1/5 times 8, that is -8/5. Now we solve this equation for y, the last step. And for that you subtract 3 on both sides. So we have y, this cancel, equals -x/5. Now what is -8/5? -3 is, so we have -8/5 minus 3. We need to have a common denominator, right? So the denominator is 5, so you multiply 5 by 5 in the numerator and denominator. So we have -8/5 minus 15/5, -8, -15, that is -23/5. So we have -23/5. And this is the equation of a line joining the given 2 points. So this exam too, you only have 4 sections, okay, and you have a 3 question from 2 section, and the remaining is from section 2.1 and 2.2. So make sure you practice the review, okay, and I expect everyone to get at least A. So you have the very less things to prepare, okay, and if you are required to use the formula, it will be on the test paper, okay. But you should know how to solve these problems. Okay, do you have any question on this one? So if not, any question? Okay, if so, let's go to number 12, okay? Okay, so we need to find the equation of a line, okay? Still we are looking for the equation of a line here. The line is perpendicular to the line, okay? Okay, let me draw a picture here. So we need to find the equation of a line. So let's say we are trying to find the equation of this line, okay? And this line is perpendicular to the line. So this line is perpendicular. So let's draw a perpendicular line here. So let's draw this perpendicular line. The angle has to be 90, right? And this line, the equation of this line is -3x plus y equals to 4. This is given to us, okay? So we are trying to find the equation of the black line here. And the line is perpendicular to -3x plus y equals to 4, okay? And the line is passing through a point 2, 0. So we know one point on this line, which is 2, 0. This is given to us. So we are trying to find equation of line 1. So let me call this is line 1. And this line 1 is perpendicular to line 2. Okay. And line 1 passes through a point 2, 0. We are asked to find the equation. And the option is, you only have the 2 options. Okay. Every time if you are looking for the equation, you have the 2 options. The first option, you're going to use y equals mx plus b. Second, y minus y1 equals m times x minus x1. Now, which option are we going to use here? First or second? We can't use the first one because it's asking us the y-intercept. So, B is the y-intercept. Okay. Or do we have the y-intercept here? So, what is 2, 0? 2, 0 is the x-intercept, right? But we want a y-intercept. So y-intercept is not given, so we're gonna use the second option. And in order to use second option, what we need to know, what else we need to know? We need to know what is the slope of a line, and we need to know what is the point x1 y1, which is given to 0. Okay, point is given to us, so this is our x1 y1. Now the only one thing that we need here is the slope of a line 1. Now how do we find the slope of a line 1? And we know line 1 is perpendicular to line 2. What can we say about the slope of these two lines? Okay, the slope of line 1 is, so how the slope of these two lines are related? Yes, so when you multiply the slope of line 1 and a slope of line 2, we get -1. Or slope of line 1 is negative of reciprocal of slope of line 2. Okay, now let's find the slope of a line that is given to us. Okay, so we are given line 2. Let's find the slope of line 2. Okay, so our line 2 is -3x plus y equals to 4. And how do we find the slope? We solve this equation for y, and the coefficient of x is the slope. So in order to solve this equation for y, we add 3x on a both side. So -3x, +3x cancel. We have y equals to 3x plus 4, and the coefficient of x is the slope. So here let's call the slope of line 2 is m2 and the slope of line 1 is m1. Okay, so here m2, which is the slope of our line 2, is 3. Since these two are perpendicular, what do we know? m1, when you multiply the slope of line 1 and a slope of line 2, which is m2, you always get -1. Okay, so when you multiply m1 and m2, we always get -1 because they are perpendicular. Now let's substitute m2. So we have m1 as it is. That's what we are trying to find. m2 is 3 equals to -1. How do we get rid of 3 from left side? Do we subtract or do we divide? Yes, because we have the multiplication here. So we divide both sides by 3. And our slope m1, which is -1/3. Okay, now we have the slope, we have the point. Now you take this point slope form and substitute. So we have y minus y1 equals to m times x minus x1. So we have y as it is minus y1 is 0 equals m, which is -1/3. X minus x1 is 2. So y minus 0 is y. So you distribute here for x as well as -2. So -1/3 times x, -x/3, right? And -1/3 times -2 is +2/3. And this is the equation of a line which is perpendicular to -3x plus y equals to 4 and passes through to 0. So you will be, so at least there will be 2 or 3 problems where you will be asked to write down the equation of a line. Okay, it will be a different condition. Okay, sometimes you might be given at 2 points and asked to find the equation of a line. Okay, in some cases it might be the pretty similar to this one. Okay, and let's do one more pretty similar to this one. Okay, not exactly same, which is number 14. Okay, do you have any question on this one? Okay, so let's go to the number 14. And in number 14, still we are asked to find the equation of a line. Okay, let's say we are trying to find the equation of this line. And this line is parallel to -2x plus y equals to -1. So we have a line parallel to this one. So let's call this is the one, and its equation is given to us: -2x y, so it's positive y equals to -1. Okay, and it's passing through a point 0, 3, and the this black line is passing through a point 03. So we are asked to find the equation of this line L1. Okay, L1 is parallel to L2. Since you are asked to find the equation, we have the two options: y-intercept, slope intercept, or a point slope form. Okay, so we have the option y equal to mx plus b, and the other option is y minus y1 equals to m times x minus x1. Okay, in both cases we need the slope of a line, which is, we don't know, we need to find the slope of the line here. How do we find the slope of the line 1 here? So slope of line 1, the line 1 and line 2, these two are parallel,
Would it be
right?
the same as line 2?
Yes, since they are parallel, the slope of line 2 is same as slope of line 1. So let's find what the slope of line 2, and that will be a slope for our line 1. So let's take our line 2, which is negative 2x plus y equals to negative 1. Okay, finding slope means you are solving this equation for y. So let's solve this equation for y, and that is, you're gonna add 2x on the both side. On the left, these two cancel, and we have y equals to 2x minus 1, and the coefficient of x is the slope for line 2. Okay, so let me call this is the slope is m2, slope is m1. So the slope of line 2 m2 is 2. Okay, since these two are parallel, 2 is the slope for our line 1. So m1 is also 2 because these two are parallel. So we have the slope, we have a point. Now what is the option to use here, first or second? Or we can use first one. Okay, can we? Okay, yes, we can use first one. And what is the reason for that? Yes, so 0, 3 is a y-intercept, right? So we know what is b here. So b is 3. So your b is 3, your m is 2. So you can substitute in the slope intercept form. So your equation is y equals to slope is 2, x as it is, plus b is 3. And this is the y equals to 2x plus 3 is the equation of a line which is parallel to negative 2x plus 1 equals to negative 1 and passing through a point 03. Okay, now so I want you to practice one pretty similar to this example and the previous one. Okay, and the remaining we'll do in our next